Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss fundamental products and idea of maxterms and minterms. Let's begin. Fundamental products. First, what is standard form of expression? When we are dealing with Boolean expressions, here if a logical function is expressed in terms of logical variables, when these variables are in binary nature, the terms building the expression may contain 1, 2 or many number of variables, then it is said to be standard form of expression. The standard form of expression we can show in two ways, that is sum of product in short form we say that is SOP. What is sum of product? As the name indicate, the logical sum of two or more logical product term is known as sum of product. Some examples of sum of product: the expression y is equal to let b plus ab plus a c complement c prime. In some book, in prime it uses the bar symbol for complement. Look at here. Here is the logical sum of two or more logical product term, that is sum of product. Here the sum of products. Another example, y is equal to let a b dash c plus a c dash plus a dash b c dash is the sum of product. Next one, product of sum. Product of sum, POS. Same thing, that is the logical product of two or more logical sum terms. Is known as product of sum. Example, y is equal to a plus b dot a plus c dash. that is the product of sum. Another example, that y is equal to a plus b dash plus c dot a plus c dash a dash plus b plus c dash, that is the product of sum, that is the sum of product and product of sum, SOP and POS. These are some examples. So, the standard form of expression, we have 1, 2 or many number of variables that are expressed either in sum of product or in product of sum. In that way, we say the non-standard form of expression, if that kind of Boolean function is written neither in SOP, sum of product, nor in POS, product of sum, then that expression is said to be non-standard form. Example of a non-standard form, y is equal to a b plus b dash plus a b c, a plus b d plus b c dash. Look that particular expression here, that expression is not written either in SOP or POS form. Therefore, that particular expression is said to be non-standard form of expression. It is in non-standard because it is neither in SOP or in POS. Therefore, that expression is a non-standard form of expression. The fundamental products type are sum of product and product of sum. Next, idea about Maxterms and Minterms. So, what is Minterms? Minterms is the product term having all binary variables of a logical function, that is the product term. In similar pattern, Maxterm is the sum term having all binary variables of a logical function. Let us prefer an example. If we take two variables, what are the possible inputs for two variables? That can be decided by a formula, number of possible conditions is equal to 2 to the power k, where k the number of variables. If we choose two number of variables, 2 to the power 2, that will be 4 number of possible inputs. If we choose 3 number of variables, then the possible inputs will be 2 to the power 3, that will be 8. So, Minterm, basically we call it as standard product Minterm, or we read it as standard product or we read it as fundamental product. So for max term we call it as standard sum, or we call it as fundamental sum, standard product, fundamental product, here standard sum or fundamental sum. Let me take an example of a two variable. Let two variables so let me prefer example as two variable. So the binary variables for two variables, let A be the two variables. So the possible inputs 0 0, 0 1, 1 0 and 1 1, these are the possible inputs. So the decimal equivalent of that two variable, so the decimal equivalent decimal equivalent 0 0 it will be 0, for 1 1 it will be 1, for 1 0 it will be 2, for 1 1 it will be 3. So when we write it in min term, for 0 that is A bar, for 0 B bar, for 0 A bar, for 1 it is B, that in the product form which is min term 1 0 B bar 1 1, so A bar A prime B prime. How we designate that min term? Min term designation small m, and in that of subscript, lower subscript, we use its decimal equivalent. So here m0, then m1, m2, m3, that for two variable inputs. Okay. Similarly, for max terms, example, let me taking two variable inputs. So the possible conditions will be 2 to the power 2, that will be 4. Here we take the binary variables, A, B as 0 0, 0 1, 1 0, 1 1, its decimal equivalent as for 0 0, 0, 0 1, 1, 1 0, 2, 1 1, 3. For max term, for 0 we write A prime 0, that is plus sign sum, B prime, next 0, A prime plus B, a plus b prime, a prime plus b prime. Its max term designation and is capital M, lower subscript of the decimal equivalent M0, M1, M2, M3. Similarly, when we prefer 3 variables as A, B and C, then the possible inputs will be 8. This is the basic idea about max terms and min terms. Next, canonical form of Boolean functions. What is canonical form? Here we discuss about standard form of any kind of expression, if that is written in sum of product or product of sum. In canonical form, that is the standard form with min terms, is called the SOP canonical form, sum of product canonical form. An example, first we write the standard SOP, standard SOP. So, SOP standard form. The expression let y is equal to b plus ab plus a c dash. Here it is 2 variables, but in first term that will be only b. Therefore, it is said to be SOP standard form. If there will be the 2 variables and each term contain 2 variables either in complement form or not, then we say it is the SOP canonical form. So, SOP canonical form we clear by using the example as y is equal to a b c plus a b dash c dash plus a b c dash. Look here, that one is a min term, it is also a min term, it is also a min term, and it is 3 variable. In each min term we have the 3 variables, so it is said to be SOP canonical form. And similarly, if the standard form with max terms, we call it as product of sum canonical form, means all variables are present. But in case of standard form, there will be missing. So, the examples: POS standard form. So, y is equal to let b a plus b, a plus b plus c dash. But in case of canonical form, POS canonical form, each term have the max terms. So, y a plus b plus c, 3 variables present, a plus b dash plus c dash, a plus b plus c dash, that is a max term. So, that kind of product of sum is called as POS canonical form. Let me represent the canonical forms by using Maxterms and Minterms. There will be two kind of canonical form, SOP canonical form and POS canonical form. Representation of canonical forms. First, let we consider a Boolean function f. Consider a Boolean function f which is a sum of minterms. Sum of minterms means SOP canonical form, that is given by the expression f is equal to a dash b dash c dash plus a dash b c plus a b a b dash c plus a dash b dash c plus a b dash c dash. That a Boolean expression is given which is a sum of minterms. So, how we represent it? By using Maxterms, by using minterms notation. First of all, it has three variables. So, the binary variables A, B, C. So, the possible input conditions will be 2 to the power 3, that will be 8 conditions. 8 possible conditions are 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So, its decimal equivalence for 0 will be A prime, B prime, C prime. For 1, that is A prime, B prime, C, A prime, B, C prime, A prime, B, C, A, B prime, C prime, A, B prime, C, A, B, C prime, A, B, C. For 0 we use prime, for 1 that value. So, the decimal equivalent of that binary variables we know 0 0 0 0 is equal to 0 0 0 1 1. So, 0 1 2 3 4 5 6 7, and in designation we write minterm designation minterms small m lower subscript 0 m0 m1 m2 m3 m4 m5 m6 n7. we expressed it by using the notation as thus f is equal to, so here a dash b dash c dash, so a dash b dash c dash, that refer to m0 plus a dash b c, a dash b c, a dash b c, that refer to m3 plus a b dash c, a b dash c, that refer to m5 plus a dash b dash c, a dash b dash c, that refer to m1 plus a b dash c dash, a b dash c dash, that refer to m4. Rearranging this, write m0 plus m1, m3, m4 plus m5. We write it in ascending order. In short, we noted it f as the variables a, b, c is equal to summation, it is in the form as 0, 1, 3, 4, 5. So that expression that is the sum of minterm expression is written in that short form. Next, another example related to product of Maxterms. Let we consider a Boolean function is a product of Maxterms as given by the expression f is equal to a dash plus b dash plus c, a dash plus b plus c, a plus b dash plus c, a plus b plus c dash. We write that product of Maxterms in its canonical representation form or by using symbols of Maxterms. It is 3 variable systems, so binary variables for a, b, c, that will be possible. Inputs will be 8, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. In Maxterm, for 0 we write a bar plus b bar plus c bar, a bar plus b bar plus C, A bar plus B plus C, A B C bar or 0 C bar, 0 1 1, A B bar plus C bar, sorry for 0 A bar. Okay, for 1 A B bar plus C bar, A plus B bar plus C, A plus B plus C bar, A plus B plus C. Next, its decimal equivalents. Zero 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 as 0, 0 0 1, 1 2 3 4 5 6 7. Its max term representation. Max term designation as capital M 0, capital M1, capital M2, M3, M4, M5, M6 and M7. Now we write it in that of notation format, that Boolean expression, or we say it as Boolean function, is given by f is equal to, thus f is equal to first a dash plus b dash plus c, a dash plus b dash plus c, therefore m1, we write it m1 dot a dash plus b plus c, a dash plus b plus c, therefore m3, it is m3 dot a plus b dash plus c, a plus b dash plus c, therefore m5, m5 dot a plus b plus c dash, a plus b plus c dash, therefore m6, it is m6. So in short, we represent it as f 3 variable as a comma b comma c is equal to summation over 1 3 5 6. From that notation we clear it is the product of max terms. That expression is written in this way. So here, with the help of this video lecture, we understand the concept of fundamental products as standard form of expression and non-standard form of expressions, the idea of sum of product and product of sum, max terms and min terms. By taking an example of two variables, how we designate max terms and how we designate min terms. Canonical form of Boolean functions as SOP canonical form and POS canonical form. Representation of canonical forms, we prefer an example and we write it in canonical form. Again another example, that is the product of max terms. and we expressed it in that notation. So, with this useful and informative notes, let me wind up this session. Thank you.